Hello, yeah, I'm back onto some math questions in this video. So I'm going to do the specimen papers that are on the Oxford site for the math. This is Specimen Test 1, issued March 2009. I'll go through the multiple choice questions in this paper. So question A, the area of the region bounded by the curves y equals x squared and y equals x plus 2 is what? So where are these intersecting? Because that will give us the upper and lower bounds of our integral. So x is 2 is an obvious one, and minus 1 as well. So that's fine. This line of x plus 2 is going to be above the x squared, and we're not getting any negative y's, so we don't have to worry about crossing the x-axis. So I'm going to have x plus 2 dx integrated from minus 1 to 2, and then I can take off from minus 1 to 2 x squared dx. So that's going to be x squared over 2 plus 2x, 2 to minus 1, take off x cubed over 3, 2 to minus 1. So I'm going to have 2 plus 4 minus a half, and then plus another 2 on all of that. So that's going to be a minus minus. Then I'm going to take off 8 over 3, and then I've got a minus 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 on this one, so I'll take off another third. So I'm taking off 3 from all of that. So I've got 8, 4.5 all in all. So C. Right, so that's a fairly standard starter. Smallest value of this function in the range 0 to 2. So we got some kind of cubic. Well, I suppose if we get our turning points on this, there's no obvious root that I can see out of this, because we got, yeah, that 12 isn't going to combine with anything and the 9. So I'll do an f dash of x, which is 6x squared minus 18x plus 12. Divide everything by the 6. So I want x squared minus 3x plus 2. I want to be equal to 0. So I'm going to get turning points at x is 1 and 2. So that's going to be, yeah, so it's going to be going like that. So that's going to be the maximum. That's going to be the minimum there. So I'm going to have a minimum there. So I need to check when x is 0 and when x is 2. So when x is 0, I'm getting 3. So that's one option. When x is 2, I'm going to get 16 plus 3 plus 24. And then I'm taking off 36. So that is 43. That's 7. So 3 is best when x is equal to 0. Okay, so that's B. C, what is the reflection of the 0.34 in that line? Okay, so which one of these? Right, well, let's just see if the midpoint between any of these, between this and any of these answers, actually lies on the line. So let's go with this one. So the midpoint here is going to be at 6, 8. Does that fit onto this? So 3 times 6 is 18, plus 4 times 8 is 32, which is equal to 50. So that works. So it's A. So that was handy they put it as A. We might have had to do that 4 times if it ended up being D, but they've given us the easy one. The equation that has how many roots in all of this? E. Okay, so that doesn't look that fun, but there's not, I'm not going to be able to get any nice factor pulled out of this. So let's differentiate 3x squared minus 60x plus 108. So I can divide by 3 on all of this. They're all divisible by 3. So x squared minus 20x plus, what's that, 36. I want to be equal to 0. So I could have an 18 and a 2. So that comes out all right, doesn't it? X equals 2 and 18. So they're my turning points. So I need to see whether these are going positive, negative. You know, I've got something like that. I need to see where the x-axis is now. So when x is 2, I'm going to get 8 minus 120 plus 216 minus 104. So that's 224 and 224. So that equals 0. So I've got a repeated root here when x is 2. This is where the x-axis is. So that comes out as D. E, the fact that 6 times 7 is 42 is a counterexample of which of the following statements? The product of any two odd integers is odd. Well, no, it's not that, because they're not both odd. If the product of two integers is not a multiple of 4, which they're not, then the integers are not consecutive. Well, we have got consecutive integers and the multiple is not a multiple of 4. So there we go, B. Right, okay, that was a bit of a gimme one. F, how many values of x satisfy this equation? So we've got that 2 minus 2 sine squared x plus 5 sine x is equal to 4. So I've got that 2 sine squared x minus 5 sine x plus 2 is equal to 0. So I can split that middle term. 2 sine squared x minus 4 sine x minus sine x plus 2 is 0. 2 sine x minus 2 minus sine x minus 2 is 0. So well, the sine x minus 2 isn't going to help, but we could have that sine x is equal to half. So I'm going to get two solutions, which is A. Well, I haven't really tested anything here so far. These have been pretty run-of-the-mill. Those inequalities are met by x in what region? Oh God, they've given us some nice boundaries here. So let's try out a few things. So if I put x as 0 in, then that one works and that one works. So it can't be that. Is it going to be, what if I put something bigger in? What if I put x is 2 in? That might be an interesting one. So I'd have 4, that one definitely works, and that one doesn't work. So I can't have x as far as 2. So it's not that, it's not that, it's B. Right, again, they've given some nice options to just work from the answers rather than actually figuring it out. Right, H, given that log 10 of 2 is that, and 10 to the 0.2 is less than 2, right? It's possible to deduce what? So these are all to do with 2 to the 100. So we've got then that 100 log to the base 10 of 2 is going to be 30.10. Okay, so I'm going to want to do, what am I going to want to do on all of this then? So I'm going to want to, actually I'm probably better off just leave it. I want to leave the 100 up there, don't I? I want to say that 2 to the 100 is going to be 10 to the 30.10. So that's equal to 10 to the 30 times 10 to the 0.1. And that means that I've got, so that's 31 digits that I've got there. And then I've got this 10 to 0.1. All right, so that's less than 2. So it must be starting with a 1 then, mustn't it? Because it's a little bit bigger than this. And it's 31 digits and it's got to start with a 1. So that's C. Okay. Then we've got I. The power of x, which has the greatest coefficient in that expansion, is what one? Right, well, it's definitely not going to be that one. So if we got an x squared, that is going to be, well, our coefficients on all of this. So we want to do a 10 factorial over 2 factorial, 8 factorial. But that's going to have 2 lots of a half in there. So that's going to be times a quarter. And then I'm going to have 10 factorial over 3 factorial, 7 factorial times an eighth. And I'm going to have 10 factorial over 5 factorial, 5 factorial. But that's then going to be times by 1 over 32. So I need to see which one of these things is going to be bigger out of all of this. So this is 9 times 10, so 45 over 8 I get for that one. This is going to be 8 times 9 times 10 divided by 6. The 8 is then going to cancel. So I'm going to have 9 times 10 divided by 6, aren't I, on that? So 90 over 6, so 15. Okay, which is bigger than that, so it's not that one. And then here I'm going to have 10 times 9 times 8 times 7 times 6 divided by 5 times 4 times 3 times 2. So that, and that go. Plus I've got this 32, 1 over 32 here, haven't I? Which I need to put in. That can make that a 2. That can make that a 2. So I've got 4 times, well, I can take those out and make that an 8, all in all, at the bottom. So I've got 9 times 7 over 8. Well, that's certainly less than 15. So I'm going to end up being B. Right. J. Well, he's a really quick set. The sketch of the curve of that is drawn in which of the following diagrams? Right, okay, so we've got, what are the differences here? We've got none of them are going through the origin, right, so I can't go with that. I've got these first two are cutting axes and the other two aren't, right, so that might be something. Am I going to be able to get that to have, well, if y is, well, actually, if y or x is 0, it's not going to work, so it's not going to be A or B. So we're looking at these bottom ones. What are the differences between these? We've got bits that are missing here. So this one isn't going in those quadrants. This one isn't going in that quadrant. So if x and y were both negative, could this ever work? We'd have positive, positive times negative. So that would never work. So we can't have anything down here. So it can't be D. It's going to have to be C. Right, I would say that's one of the easiest sets of opening questions I've seen on one of these math papers. So yeah, there you go. That was a very swift collection, wasn't it? So I don't know, not much to say about it really. They were all fairly straightforward. So there we go. I'll move on to the rest of the questions in subsequent videos.